So, welcome to our second video on numbers in different bases. Like I said in the last video, in this one we're going to be concentrating on converting decimal numbers, so numbers in our standard base 10 system, into binary numbers, numbers in a base 2 system. And you'll be pleased to know that there is a really simple way to do this, a simple way to figure it out. But first of all, I'm going to show you the procedure that you would need to take if you were going to think it through logically on your own, and then just the procedure you can follow each time that will work each time that you don't even need to think about. So let's have a look at number 1. We have the number 13 in our base 10 system, and we know that we need to create the number 13 using powers of 2. So we have 2 to the 0, which is 1, 2 to the 1, which is 2, 2 to the 2, which is 4, 2 to the 3, which is 8. And I'm going to stop there because we don't need any more. I mean, 2 to the 4 is 16. We could carry on if we wanted to, because 16 is already bigger than 13. The question I now need to ask myself is, which of these numbers would I need to add together to make 13? Well, that seems quite clear. I mean, all of these are even numbers, and this is an odd number. So I'm going to have to add a 1 at the end, and then I need to make 12, which I can make as a combination of 4 plus 8. So I'm going to need 1, 2 to the 3, 1, 2 to the 2, and 1, 2 to the 0. I'm not going to need any of these, and I'm not going to need any of these. So, my final answer, because my powers of 10 here go in an ascending way, and we work normally from right to left in terms of increasing values of numbers, I need 1, 1, 0, 1 in base 2. Because I need 1, 2 to the 3, 1, 2 to the 2, and 1, 2 to the 0, and so we go in decreasing amounts from our thousands to our units. Now this is the way you could think it through, but obviously for the number 89 you'd be writing a lot of powers of 2 and you'd be thinking it through. Let me show you the way you can do it with just simple division. So the procedure is that we take our number and we divide it by the base. So this is the base that we want to have, and I say that 13 divided by 2 would be 6, remainder 1. We don't need to work with decimals here. Then I take this number and I feed it back into the same thing. So I have 6 divided by 2 is 3, remainder 0. And notice that I keep the base the same in each of these calculations. Then I feed the 3 back in. 3 divided by 2 is 1, remainder 1. And I'll keep my ones the same. Feed the 1 in. 1 divided by 2 is 0, remainder 1. And when I get 0 here, I stop. And you'll notice that the remainders that we have actually form the number. If you then read from bottom to top, you come out with 1, 1, 0, 1, 1, 1, 0, 1, which is the base 2 number that we'd figured out from our powers of 2 here. So I'd like you to use this process here to try 2 and 3 on your own. You'll notice that the bigger the number gets, the much bigger the binary number gets. In binary, it takes a lot of space to write even numbers that seem relatively small in the decimal system. And that's something you'll notice. The lower your base is, the more digits you need to express numbers. And the bigger your base, the fewer digits you need to express numbers. So please pause the video and try the number 2 and 3. Then I'll do them in the video and you can check your answers. So I've assumed you've paused the video. Let's go then for number 23, base 10. And we want to write it in binary. So 23 is divided by 2 is 11, remainder 1. 11 divided by 2 is 5, remainder 1. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 1, remainder 0. And then 1 divided by 2 is 0, remainder 1. And so now we have our binary number. I just read up from the remainders. We have 1, 0, 1, 1, 1, base 2. And you can check this really quickly in your head, in that you can say this is 1 from this digit, plus 2 plus 4, so that's 7. Not plus 8, but plus 16. 16 plus 7 gives us 23. Yep, that works. And if that was a little quick, you could always write these out properly in terms of their powers, as we did in the examples in the previous video, to convert them back into base 10 and see that you get 23. If you were, for example, in a test situation, I'd recommend being absolutely sure. So hopefully you managed to do that one perfectly well on your own. Let's try our next one then, 89. So we have 89 in base 10. So 89 divided by 2 is 44, remainder 1. 44 divided by 2 is 22, remainder 0. 22 divided by 2 is 11, remainder 0. And then we end up in the same pattern as we were before. So we have 5, remainder 1. 5 divided by 2 is 2, remainder 1. 2 divided by 2 is 1, remainder 0. And 1 divided by 2 is 0, remainder 1. And then I just read up from the bottom to get 1, 0, 1, 1, 0, 0, 1, base 2 in the binary system. And you can see that 89 only requires 2 digits in the decimal system, but in the binary system it requires 7 digits. So you can imagine that numbers in their thousands in the base 10 system would really require a lot of digits to express them in the binary system. So hopefully this procedure is clear to you. And you can also, if you want to get used to the idea of conversions, then you can do it like this in your head to begin with, and then check it this way if you want to. But I would recommend going for the faster way. But of course it's up to you. Again, if you have any questions, write me a comment on the video, or please put a note in your book, and then we can discuss any questions you have in class. I hope you enjoy the holidays.